everybody. Welcome to this component spotlight with Partel and with Hugh Whiriskey, the co-founder and technical director of Partel. So Hugh Whiriskey is, as I said a moment ago, the founder and the technical director of Partel. Established in 2011, Partel produces and supplies high-performance, energy-efficient systems for the green building sector. They're based in Western Ireland and have a presence throughout Ireland, the UK, North America, and recently mainland Europe. So they're also a founding sponsor of the House Accelerator, and we're very happy to have Hugh here today to share with us. So Hugh, with that, why don't you take it away?
Great. Thanks for that, Zach, and thanks to the Accelerator for having us. I'm going to share screen now. Zach, you can probably give me an okay if I've done it correctly. Okay.
Looks good.
Great. So yeah, today we're going to be taking a look at the self-adhered systems, particularly the product EXOPERM MONO 250 SA. As Zach said, I'm the CEO and founder of Partel. I'm a certified passive house designer and technical director of Partel. I take care of all of the product development and I suppose the general technical aspect of all kind of parts of Partel. So today we're going to take a look who are Partel, why are we building AIRTIGHT and Weathertight. We'll really focus on what goes into the product EXOPERM MONO 250 SA. We'll be looking at some of the complementary product systems, the technical support and services that you can have from Partel, and we'll be taking questions after that. So as Zach mentioned, we're operating in quite a few different areas at the moment. We're working directly, if you like, in home markets in the UK and Ireland and North America, and we're available throughout Europe through a number of, I suppose, registered distributors. We are founded by architects and engineers, and that's very much kind of how the company is still led or guided. With a really strong knowledge in building physics, and most of our product development comes in that kind of direction. We still offer, I suppose, really comprehensive and thorough technical expertise and support, and are always working on kind of new and maybe some interesting products, and you'll start to see some more kind of products in addition to the self-adhered over the next couple of months. So why are we building AIRTIGHT and Weathertight? A couple of the main things that people look at is to lower our energy costs. And while it's true that that's kind of really important, there's a few related factors that are equally important. So a big one is to improve our comfort levels. So if we've got the right level of air tightness and weather tightness, it typically means that our R values, our U values, are as designed. So the calculators that we use to, I suppose, to work out those figures always assume perfect air tightness or weather tightness. So achieving those means we get the design values on site. So it closes the performance gap. I guess never, more relevant now than it was is air quality. So it's got a really big impact on controlling the air quality, and from the inside that can be how products break down over time, or even filtering from the exterior. The last point that we kind of always focused on is structural integrity. So everything we use is a system, and we're focused on having a wall built up that can dry, something that can be designed to, I suppose, to manage the moisture in the construction and create it after construction. So looking at the EXOPERM MONO product systems, there's I suppose, EXOPERM MONO 150, which a lot of you will kind of already have used. It's an all-purpose membrane, wall and roof membrane. Well trusted, tested, and I suppose a very well liked product. We have the EXOPERM MONO Duro, which is an enhanced fire rated UV stabilized TPU product, and the latest one that we're looking at today is the EXOPERM MONO 250 SA. That can be used in walls, roofs, in flat roof situations, and I'll go through those in a little bit more details in the next couple of slides. So why are we looking at this area that closely? So the relationship with timber and moisture is set to become more important over the next number of years as we all look at, I suppose, reducing the embodied carbon in our buildings, and timber is a key component for that. So normally what happens when there's a change in construction is that everyone moves that way first, and we start to develop the issues, find out what we were doing wrong. So that there's a chance to avoid a lot of that. So you see this type of construction going on. I guess where we're from, or where Partel's head office is, has about 1 or 2/3 of our days have more than 1 millimeter of rain. So we're very used to the damage and the impact that rain has, but it doesn't actually need that much. So we know that there's varied conditions pretty much in all regions these days. So the necessity to protect our timber, to ensure that things can function post-construction is really important. Um, Most of the systems that we're using these days in construction depend on the right level of construction moisture or the timber content. So we buy the timber, it's maybe 13, 14% moisture content. And, you know, because of how it's installed, or just the weather during installation, we can get really serious problems. Um, the example here, I'll look at a little bit closer, but we see party walls in between dwellings. It's an interesting area in the UK and Ireland where there is some regulations for those types of walls to be constructed completely in factories. And I would say kind of generally, as the industry moves more towards offsite panelized production, there needs to be ways to keep them dry during construction. Flat roofs are a pretty important area. I guess still quite common, and at the moment a good deal of confidence about flat roofs because there's really good quality exterior products. But when we always look into these systems, if we increase the construction moisture in these flat roofs, it can be enough to simulate failure on its own. So things like we're looking at here, mold during construction, or just a high moisture content in structural beams, can create a failure maybe 2-3 years down the line. This is a fairly typical kind of detail for Ireland, where party walls, so dividing walls between houses, have to be completely constructed, delivered to site, without any adjustments, and it's down to a regulation on fire. So quite often they're wrapped in plastic. That plastic is taken away and disposed of, or sometimes it's left in place. And in a perfect world, it can keep the party walls dry, but we know that a better solution is to wrap them with a breathable membrane, so something that can be left in place and will allow the plasterboard to dry to the exterior post-installation. There is a lot of studies out there that can show us, I suppose, the impact of an outer CLT construction, what happens when we cover it, and it's a pretty, if you like, a soft study, this one. It's from KTF University, or KTH University in Sweden. The accumulated rain content is actually quite low. It's about 900 millimeters. So where we live, that can be up to 2,500 millimeters. Not always, but it depends on the region. But the impact of, I suppose, of a covered layer on a CLT floor is shown in blue. So it has the possibility of keeping the floor or the CLT element down at about 15% moisture content. And, once we open that up to rain, you're looking at essentially a failure, 20-25%. And like I say, this isn't a worst case situation. There is also complexities with how manufactured timber dries. So if we look on the left, we've got a typical wood structure and how it might dry. This is a CLT, or plywood would be in a similar way. So it dries differently and can lead to different issues, like the earlier slides we saw with, I suppose, with CLT failures. So the solution can be EXOPERM MONO SA 250. It's a fully self-adhered monolithic membrane. It's a 6-layer product. It has, from the outside to the inside, a UV stabilized protection layer. Our monolithic TPE film underneath it, that's an incredibly breathable product, but also watertight. Inside that, we have a protective PP layer, a grid reinforcement film, and then our high performance acrylic adhesive and clear split liner. I'll get into those layers a little bit further But just to look at some of the key advantages, the breathability figure that we have at 13 perms or 0.26 SD is extremely vapor open for a self-adhered monolithic product. It isn't just the membrane that's UV stabilized, the adhesive itself is also UV stable. And we see it as a product that can be a real long-term protection for the assembly during construction and for afterwards. Our adhesive, as we know from our tapes, is a very breathable product and really doesn't affect the breathability overall of the final installed product. The split release backing kind of means that the product can be very easily applied. We can kind of hang it from one side and easily roll out the rest of the product. And the fully self-adhered surface means a very quick and easy installation. It also comes with our 10-year system warranty. Again, I'll look at that in a bit more detail. So why do we consider a self-adhered product on a wall or on a flat floor or temporary protection? What's the benefits? Why is it different? In a wall situation, the space between the membrane and the OSB or the let's say MDF type breathable board, that layer itself or that airspace can actually facilitate the buildup of water vapor. So to have it adhered, it's actually, it's really joined on all parts right to the OSB or the timber layer, and means that there's no kind of risk of buildup, with a loose product. Another kind of huge and maybe obvious benefit is that we don't need fixing. So there's no additional penetrations in the product. There's no risk from tearing of those kind of nails or fixings that people might use. And I suppose a very real or practical issue that people get on construction sites is tearing based on loose materials. So when panels are being moved, it can be quite easy to tear them if they aren't self-adhered. And finally, the really interesting benefit is because it's a monolithic layer with the right type of adhesive, it will self-seal where screws or staples are used. So looking at the adhesive itself, we're very much focused on a solid acrylic adhesive. So it's a pure acrylic base, low VOC. It requires pressure post-application. So it takes 24 hours to reach its full strength, but is excellent at, I suppose, for temperature resistance, to withstand moisture, can be used internally or externally. But it's kind of something we always focus on here, and this graph is interesting that it's quite easy to be the tackiest product on the market, but we know that the balance that we provide delivers the best long-term strength. So that's really what we're focused on, a balance between peel, tack, and cohesion. And the target is to have the longest lasting product. The next key layer, the monolithic products. So some people might be aware that there's two ways that a breathable or membrane can be breathable. We have the older technology, microporous. Microporous membranes have physical holes, and they're actually, I suppose, a little bit cheaper to produce, often joined 3 layers by heat solely. But the real issues with those is the layers can become blocked, and the passage of water vapor can quite easily be stopped. Whereas the monolithic layers use a solid breathable polymer. That's our system. All of our membranes use this type of technology. And we can transfer the water vapor from inside to outside in a molecular way. So there's no risk of any pores in the membrane becoming blocked. We also have UV stability built into the monolithic layer. So altogether, we're looking at a product that'll have a much better longevity and I suppose consistency with breathability. So in terms of where the product can, or how it can be applied, it can be applied vertically or horizontally. It sticks to most construction materials, and you could look at, the main ones it'll be applied to would be plywood, OSB, CLT, metals, plastics, and gypsum boards. The surface should always be clean, dry, and smooth, and it's logical to carry out adhesion tests to check the surface before you start to apply. Occasionally, you can have surfaces that have been impacted by oils or grease, dust. So yeah, that's kind of the idea for the check. We can work from -10 degrees Celsius or -15 Fahrenheit, and it is very much part of a complete product system. So if we look just at the exterior, that is the the tapes for sealing around penetrations, Connexo multi-seal, Conlex butyl for flashing or seal pans. Cab seal is for grommets. VERMONT is a liquid adhesive that can be used in difficult conditions, and we have a couple of different primers that can be used on porous or uneven surfaces. Just to take a look at how the product is actually applied. So we see here post-application pressure being applied to the product. Pressure is a very important part of it, and that's key to activate the adhesive. Normally, people will quickly set a mark on the surface they're applying to, tack or hold the membrane on with its own adhesive, and yeah, start to apply the pressure. I'll show a video of that in a minute, but it's a product that's very hard to install incorrectly, and that's a huge benefit on construction sites. If it's easy to apply correctly, chances are we're going to end up with good results. The adhesive itself facilitates repositioning, so you do get a second chance with the Partel product. So even if you pull off too much the release liner, you will get a second chance. It's a product that will be used in factories quite a bit, so we will see timber elements being protected or gypsum in factory. So very quick and uncomplicated to install. So looking at where the products can be used, it's equally applicable to commercial or residential. It can suit the high-rise buildings right down to the single family. It would have a good fire rating if used on cement boards, so can be part of a fire rated system. We expect it to be, and already see it used in roof walls, ceilings and floors, so quite a broadly used product. To look at some of the technical performances in a little more detail, it is a continuous airtight layer. So subject to woofy analysis, you can use it as your airtight layer. It's a really good option for that. It is also vapor open, so 13 perms, 0.26 SD, but very much a high quality WRB membrane. This is something that we're, I suppose, quite keen to make aware to people as something that's available, the 10-year system warranty. It's an integrated solution, and our warranty is quite broad. So if there's a Partel product available and you decide to use it, it's automatically applicable to have a 10-year system warranty. In terms of testing, we have already completed CE and UK CA marking. The product is being certified at present or tested with the Passive House Institute and will be validated through BBA. So both of those are ongoing already. To look at how the product can work and how that would work from a building physics point of view, we took two main applications. So the first is a flat roof. This is a timber deck flat roof with the EXOPERM MONO self-adhered product applied directly onto the plywood with a layer of insulation over it, and then a typical flat roof membrane. We call this a hybrid roof. It's got full fill insulation underneath that and a smart vapor control layer to the underneath. This type of buildup is quite good for low energy construction. It minimizes the roof depth, but really allows us to get a good connection with our air tightness layer to exterior walls. The self-adhered product can be left in place. So, its main job here is to act as a temporary protection layer to the plywood. So we modeled it in woofy. I'll show the outcome now, but quite interesting feedback. We took a location in New York, looked at the performance of the overall moisture content, and pretty quickly when you see a graph like this, things are going to be positive, but the key layer is always the timber layer or the point where the moisture could accumulate. So looking in at the plywood layer in particular, because the simulation was started in November, that's if you like, right in the winter period, we'd expect an increase in moisture content, and then, if the construction is correct, a quick drying after that. So, you know, after 3 years, we're down to about 12% moisture content in the timber. So really, really effective system. Pretty unusual for a flat roof that it would be able to dry that quickly, but it shows the advantages. And I suppose the real security here is that by using that self-adhered product in that location, we can have confidence that there hasn't been a buildup of unwanted construction moisture in the plywood layer. To look at a more typical timber frame wall with cellulose insulation, smart vapor control layer on the inside, and the self-adhered product to the exterior. Again, really, really solid performance. We're looking at moisture contents down around 9% after 3 years. So where's the product available? It's available in the US, the UK, and Ireland. You can buy it online or direct contact with us to, I suppose, to consult or check your construction type and how it matches. There is a number of complementary building envelope systems from Partel that work very well with the self-adhered EXOPERM range. We have the sheet applied VARA Plus. It's a smart vapor control layer, and this really is a smart system. So the fluid applied, also VARA fluid, is I suppose a really interesting and a product with a lot of different applications. It has high UV stability itself, so can be used to the external as well. We do carry, I suppose, a fully variable tape system. So it means post applications, entire system carries that smart function or variable function. And I suppose for those that might like a refresh in that, the variable function really gives us enhanced protection in our construction. So it'll give us a lot of protection in winter from higher levels of moisture and the ability to dry very, very quickly in the summer. So that coupled with the exterior protection, we're looking at a very safe system. We have in our range a smart pre-compressed tape, so a really nice option and actually works very well when we choose to do I suppose an external air tightness system. If we bring the airtight or the self-adhered product around the window joist, we can just use CompreSeal 3V BG1, and that can be your sole solution for air tightness. We do a lot of internal testing for our products. Same applies for the self-adhered, so we can test it on all substrates. If there's something that you need to check that's different, or you want to test it as part of your system, it's easy to do. Just make contact and we can, I suppose, provide that backup. We do a lot of work with thermal bridging. Most interesting system for us, and I suppose a quickly growing solution, is a structural thermal insulation called Almavert. It's made completely from recycled plastic bottles. It's able to take, really large weights, so it can take the weight of any of your sliding doors, windows, or if there's external wall insulation, it's a really solid product for that. You can treat it like a piece of hardwood timber. But yeah, very, very easy to work with on construction sites. So to take a look at some products that have used the EXOPERM system, this is a new build in Vermont, Montpelier Construction. It has a drainage plane, which we kind of always recommend, but yeah, achieved really interesting results from I suppose, an energy from a new build. I think the final air changes were below 1 ACH at 50. So a nice full system using VARA Plus and the EXOPERM range. This is a new build project in Ireland where the EXOPERM MONO Duro was used. You can see the unprinted version because it was for open joint facades, so some visibility. So a clear product used to provide maximum UV stability for where the open joint facade was used. So overall, what you can expect from Partel is a system and product warranty, design indemnity, insurance backed, a lot of external and internal testing. Like I mentioned, the internal possibilities. a lot of technical advice, and we're quite happy to consult, and that's kind of how we're used to recommending our products based on, I suppose, a consultative specification. That can include site-specific woofy condensation risk, specialized training, U value or R value calculations, and on-site inspections. So yeah, for the Q&A, and back to Zach, I guess.
Fantastic. Hugh, thank you so much. And really, really impressive a lineup of products there that you've gone through, and it's exciting to see the new ones. So let's start with Harvey Manook and his question. I want to just remind everyone that this is, as you have questions of Hugh, please pose them in chat, and I'll be tracking those and organizing them, and keeping the Q&A going. So the first question is from Harvey.
Oh, I didn't know I was speaking, but sure, no problem. Let me just go back to where I was in the chat. Yeah, was this on the spec? You're a self-adhering, but we, as you know, I think it was last month was flashing month. So I've read somewhere some of the products will say before at the bottom of your wall assembly, put down your tape first, then put your self-adhered membrane, then put your flashing, and then tape it again. And what they were worried about is that when the screws were going in to the membrane, that they wanted to make sure that they were actually adhering properly and closing off. So I was just wondering what your spec is on something like that, and if I have the spec right.
Yeah, I guess it depends on what we're connecting to at the base. But the product itself will self-seal with screws. So we're actually not worried about that detail so much. But if you are sticking to a different surface, we will sometimes recommend using the VERMONT adhesive in addition, which could be, I suppose, an additional barrier where you meet I suppose, the subgrade concrete. But it depends exactly what you're dealing with, but you can be very confident that the membrane self-seals if it screws.
And if it's screwing into, you're saying if it's screwing into timber versus screwing into concrete. Okay.
Exactly. Yeah.
Okay. Thank you. Thanks, Zach.
You're welcome.
Yeah.
Cheers.
Thanks, Harvey. Next up is Desid Dasan. Desid, are you able to unmute yourself and ask a question, or would I? If not, I can ask it for you. Okay, I think I'm going to go ahead and ask it. So the question is, why is there no chance to wrap up each wooden panel in waterproof plastic foil, deliver them to the site, and as such, assemble them with that protection against rain? Later, you throw away the foils, but the real foils, brick on pallets, are protected with cheap foils, aren't they?
I guess we've seen that approach be tried quite often, and in an ideal world it works really well, but in reality on construction sites, small leaks or damage to that cheap plastic are enough to allow quite a bit of water into closed panels. So that seems to be the real world practice, is that it really just doesn't work long term. So yeah, you'll get some damage on those cheap plastics. So the chosen product does need to be robust. If it's self-adhered, it'll be, I suppose, free of any kind of, it's not loose, it'll be quite tight and less likely to get damaged.
Great, thanks, Hugh. Trevor Harris, you're up next.
Yeah, I wanted to ask two questions. One was the PSI rating for the Almavert, and also if there's any difference in permeability, if there are materials actually in contact with the membrane, so that there is water connection between the membrane and whatever material it is, or an airspace between the membrane and whatever is beyond.
Yeah, got you. So I guess generally we recommend full fill insulation. Unvented airspaces can be an area that will facilitate a buildup of water vapor. That would be normally how we would recommend things. That said, the monolithic products perform very well if there's an airspace. So if that's, let's say, a cold roof, they have been shown to kind of achieve very, very high rates of breathability compared to microporous products.
And the PSI rating for the AlmaVert?
I would struggle to recall that off the top of my head, along with a lot of other things. Sorry, but I'd be happy to send it on to you afterwards. It's very, very comfortable with any fenestration situations.
Thank you.
You're welcome.
Thanks, Trevor. All right, next up is Ian Robertson. Hey, Ian.
Sorry, lots of buttons to push. I was wondering mostly about availability of that AlmaVert because contact phone's quite unavailable sometimes. How is it? And also how is the availability of everything else you've mentioned in North America, specifically in Canada, but North America in general?
Yeah, you got it. So we have quite a good stock in Connecticut, but we are working with lots of Canadian companies already. So yeah, there's availability in Ottawa. There's people using it there, and I would say definitely quite a few people already using AlmaVert and the systems in Canada. So no real problems. I mean, if you spec it and drop us a line, we can work that out.
Cool. Thank you.
Great.
Cheers.
Thanks, Ian. Okay, Ben Larson.
Technology is a wonderful thing.
Yes, indeed.
I was wondering if you looked at developing a fluid applied membrane. I've had some issues with the self-adhered. I mean, they're far and away better than the loosey-goosey stuff you mechanically fasten to your exterior building. But I mean, with regards of fish mouths and having to cut out sections and patch and all that stuff, is there something that you can that would help the contractor out?
Yeah, I mean the VARA fluid product can be used externally, so it can be used as a component part, so you can use them both combined. It's got 12 months UV stability, so no real issues with using that in localized areas. In terms of I suppose less localized, we don't have an exterior or solely exterior product, but yeah, very much you can work with VARA fluid and the self-adhered as a system.
Cool.
Great, thanks, Ben. So, Hugh, I wonder if you might take a moment to talk a little bit about the variable technology and how that works. I'd love to, and I've heard you explain it before, but for folks who might be new to some of the kind of the way the physics and the chemistry works for that, I'd love to hear about that.
Yeah, you got it. So it's really based on, I suppose, relative humidity and the humidity in contact with the membrane. So the way our product is developed, it looks like a 3-layer product, but really it's a 5-layer product. So the polymer that we use is a 3-part system. It's got a section in the middle that expands and contracts depending on the humidity conditions it's encountering, and that's actually what opens and closes. So what you'll find in winter when typically in I suppose a cold or mild climate, that the relative humidity levels mean that the membrane will become quite closed in winter. So it kind of forces that middle layer to swell. And in summer, it'll become quite open as the relative humidity is more similar internally and externally, and temperatures. But it's a combination of temperature and relative humidity.
Great, thank you. So I think we've made it through our, oh, good. We have another one here. Mark, fire away.
Hey, Hugh, wonderful presentation, and those examples are also beautiful, so that entices folks that maybe aren't as techie. Today, a lot of those projects you referenced that use the products came from the offsite community, and
yeah.
How do you think we could best bring North America up to replicate all the offsite production that's going on so well and the reason it's going on?
Yeah, I think I suppose the reasons are, thanks Mark for the compliment first, but the reasons it's changed are kind of twofold. It was partly due to regulations, but in Europe and kind of as it is in the US, there's labor issues. So to produce in a panelized closed panel system means that a lot of things can become standardized quicker, repeated, and less skilled labor is actually required. It's less time on site. Safety is also a huge issue in Europe. So the incidents on site are way, way down in panelized construction. So you're looking at kind of labor, safety, costs ultimately improve as the systems become standardized. But that's kind of how I would look at it as the main things. Going on to the regulatory side of things, we've found that it's easier to be more accurate with offsite panelized construction than it is with, I suppose, pretty much everything on site. So things get more accurate, dramatically so, and there's a much lower defect issue with panelized construction than there is on site. I'd say that that's kind of the main thing, Mark. But yeah, like you say, standardized and repeatable.
Thanks, Hugh. Thanks, Mark. Harvey, thank you for the question about horizontal installation. Can you come on and ask it?
Yeah, I'm just looking at a detail right now that we have helical piers, and we have an uninsulated crawl space with. And so what I'd like to do is actually come up and onto the wall with the self-adhered membrane. I'm just wondering, if it's installed on the horizontal, is there an issue of it staying installed on the horizontal versus it being on a wall on a vertical?
So like, I'm not completely sure of your application, so I hope I give the right answer here, but it definitely can be installed horizontally or vertically, no issue there. I guess the thing to check would be, is the layering correct for breathability? And a quick check on that would make sense, and happy to, chat to you on that again, but or get your feedback on it.
This is the famous, we call it here in Canada, or specifically in Toronto, it's the famous shoemaker house, that a shoemaker actually made the house. And so little nails and did a 1/4 inch sheeting. So it's a bit of a mess. So from a breathability point of view, there isn't any insulation in there. So they've, for years, have had this crawl, like, I don't want to even call it a crawl space. It's sitting on helical piers, and it's always cold. So I was just thinking of putting a self-adhered air barrier onto it, either mechanically fastened or if it has to be self-adhered, like a glue on. I want to make sure that when we put it on, it stays on. So that's really what it is. It's not tying into anything other than if you did a red line test, it would go all the way up. But that's it. There's no vapor control layer that it can be adhered to either, because it's finished. It's actually where the kitchen is, so it's finished space.
Okay, so will you be introducing insulation over it, or I guess there isn't room for that?
Underneath it. So we would put the self-adhered membrane, and then we would put Rockwool and comfort board. Yeah,
it's probably a little bit of a question mark, Harvey, because probably a vapor control layer would need to be on the warm side of the insulation.
Yeah, no, I understand it. This is on, it's on the exterior, so it's outside, yeah. So it has to be an air barrier, not a vapor controller. Yes, no, I understand that part. It's more of, I'm just wondering if the adhesion will last for.
Yeah, that side of things, no issues. Yeah, no issues on that. Yeah, the shear strength of the adhesive is really quite high. So that's kind of the worst load that you would apply. So the type of adhesive that we use would, it's what's the best way to? I was going to say its main strength is its cohesive strength, kind of. So that's kind of what it's known for. Yeah.
Okay, great, Zach. I won't ask the famous Harvey question now. I'll leave that for another time.
Harvey, this is your chance, man.
No. I'm trying to be a good boy. Mark has been telling me if I keep this, if I'm not a good boy, I got to grow a beard like his. So I'm sticking to the shit.
That's awesome. Well, I think that is the questions. We've gotten through the questions. So I want to, unless there are any last minute ones here as I start to wrap up, I want to give Hugh and Partel a big thank you for this presentation and for your leadership in the industry. So thank you, Hugh.
Exactly.
Yeah, absolutely. And thanks everybody for being here for this component spotlight. It's been really great. And we'll see you next time.